Hello and welcome to the first class of our calculus series. In this video we will review graphs. We will look at how to sketch a graph, finding the intercepts of graphs, symmetry of a graph, and finally point of intersections. But before we begin, let's look at some history first. The graph of an equation was first introduced by the French mathematician René Descartes. He combined the two major fields in mathematics, algebra and geometry. He did this by introducing the Descartes coordinates plane. We will use this coordinate system to graph our equations. This allows us to formulate geometric concepts analytically, and our algebraic concepts can be viewed graphically. This is very important in calculus to view problems from a different perspective. By viewing a problem graphically, analytically, and numerically, this will help you to understand the problem and the concepts more. Let's look at the example. Let's say we have the equation y is equal to x squared plus 2, and we want to sketch this graph by point plotting.
To sketch the graph y is equal to x squared plus 2, we will first construct a table of values. So we will choose values for x, so I'm going to choose from -3 up to 3. And then we can go and calculate the y values. Once we have all the coordinates, we need to go plot all these coordinates on our xy coordinates plane. Once we have plotted all these points, we need to go connect them with a smooth curve. So we can see this will give us a parabola. So let's quickly go connect these points. So now we have a sketch of our graph of the equation y is equal to x squared plus 2 by doing point plotting.
Now let's talk about the disadvantages of using this method to plot a graph. In the example we just did, we can see the shape is a parabola. But let's say we have a more complex function and we only choose a certain amount of x values.
So we have this equation here and we want to go plot this. So let's say we choose x values. I'm going to choose -3, -1, 0, 1, and 3. And if we substitute -3 inside this equation, we'll get this as -3. If we substitute -1, we'll get -1. If we substitute 0, this will be equal to 0. If we substitute 1, we'll get 1. And for 3, we will get 3. So if we go plot these points, so at -3 we'll have -3, -1 we'll have -1, 0, 1 and 1, and then 3 and 3. So you'll see that we will get here a straight line, which is not true. So let's look at this same equation again, but this time we're gonna go from -3 up to 3, and we're going to increment with 0.5. So we're going to keep adding 0.5. So if we go calculate the y values, we will get the following. So we will get the following y values. So I'm going to go and use Desmos, which is a free online graphing calculator. And let's go plot all these points and then connect it with a smooth curve. So here is all our points. So if we now go and connect this with a smooth curve, we will get the function to look something like this. So we can see now it is much more complicated than just a normal straight line.
I want to pause here quickly and discuss on how would we calculate the y values for a difficult function like this by using our calculator.
The calculator I am using here is a Casio FX991ES Plus. So on this calculator, we will have a table function. So this will be available for most scientific calculators. So if we go to mode, and you'll see here at number 7, we will have the table function. So this allows us to go type in a equation. So now here we can go type in our equation, which is 1 divided by 30 times x, and here we will have the bracket, And inside we will have x to the power of 4 minus 10 x to the power of 2 plus 39. So now if we press equal, some calculators will allow you to add one more function. So for the second function, we're going to just say 0. So where will we start? Well, we started from -3 and we end at 3 and we step through 0.5. So remember the increments was 0.5. And now if we press equal, we can see we have the value of the function for the chosen x value. So here we have from -3 up to +3.
The next important part we're going to look at is the interception of a graph. This is two types of solution points which is important for us when we go graph an equation, which is the points where there is either a 0 at our x coordinate or at our y coordinate. These are the intersection points, and this is where our graph will intersect our x-axis or our y-axis. The point A0 is an x-intercept of our graph of an equation. To find the x-intercept of a graph, we will let y be equal to 0 and then we go solve for x. The point 0b will be the y-intercept of a graph of an equation. To find the y-intercept of a graph, we will let x be equal to 0 and then we will go solve for y. Something to note, it is possible to have no interceptions or we can have several interceptions. Let's look at the following 4 examples.
In this example, we have a function that gives us an ellipse, and we will see in this function we have no x-intercept and no y-intercept. In example 2, we have a parabola, and we can see there is no x-intercept, but we do have one y-intercept at the point 0, 2. So we'll have a y-intercept, and if we go write our coordinate, that will be at 0, 2. In our third example, we have a polynomial of a third degree, and we can see here we will have 3 x-intercepts. So the first one is between -2 and -1, and then we have an x-intercept at point 0 and between 3 and 4. And if we look at our y-intercept will also be equal to 0. In example 4, we have a function that will give us a x-intercept at -2, and here we have 2 y-intercepts that is between 0 and 1, and we have an intercept between 0 and -1. Let's look at the following example together. Here it asks us to find the intercepts, if any, and we were given the function y is equal to x squared plus x minus 2. So remember, when we go find the y-intercept, we will then let x be equal to 0. So we will have y is equal to 0 squared plus 0 minus 2. So our y-intercept will be at y is equal to -2. So that will be the point 0 and -2. And if we go and look for our x-intercept, we will let y be equal to 0. So we'll have 0 is equal to x squared plus x minus 2. And if we go factorize this right side, we will have 0 is equal to x plus 2 and x minus 1. So now we have x plus 2 is equal to 0 and x minus 1 is equal to 0. So if we subtract by -2 on both sides, we will have x is equal to -2, and if we add 1 on both sides, we'll have -1 plus 1, so that will give us x, and 0 plus 1 will give us 1. So we will have the x-intercepts at -2 and 0, and 1 and 0. Let's look at one more example. So here again we're going to find the intercepts if there is any. So remember, to find the y-intercept, we will put x is equal to 0. Okay, so let's go find the y-intercepts here. So we will have y is equal to 2 minus the square root of 0 divided by 5 times 0 plus 1. So this will give us 2 divided by 1, so that will be equal to 2. So our coordinate will be 0 and 2. And if we go find the x-intercept, so remember, then we will say y is equal to 0. So we'll have 0 is equal to 2 minus the square root of x divided by 5x plus 1. So if we multiply both sides by 5x plus 1, we will have 5x plus 1 times 0. That will be equal to 0. And if we multiply here with a 5x plus 1, these two factors will cancel out. So we'll be left with 2 minus the square root of x. And now if we subtract negative 2 on both sides, so if we have negative 2 here and a negative 2, we'll be left with negative 2 is equal to negative square root of x. So let's multiply throughout with a negative. So we'll be left with the square root of x is equal to 2. And if we take both sides to the power of 2, we will then have x is equal to 4. So we will have a x-intercept at a point 4 and 0.
The next part we're going to look at is the symmetry of a graph. If we know that the graph have symmetry, this would be very helpful to us because then we only will need half the points to go sketch our graph. So we have 3 types of symmetry. Let's quickly look at these 3.
The first one we're going to look at is when a graph is symmetric with respect to the y-axis. Whenever x and y is a point on a graph and we have a point negative x and y, which is also a point on a graph, this will mean that the portion of the graph to the left of the y-axis is a mirror image of the portion to the right of the y-axis. And how we test for symmetry, so this function we had here is y is equal to x squared minus 1. So how we test for symmetry with respect to the y-axis is, we will replace the x by negative x and see if we get the equivalent equation. So if we take our original function, we're going to say y is equal to, so we're going to replace in x with negative x. So we're going to have negative x squared minus 1. And what is negative x squared? That will always be a positive value. So we'll have y is equal to x squared minus 1. So now we see that these two equations here is equivalent. The next one we're going to look at is when a graph is symmetric with respect to the x-axis. So whenever we have a point x and y, and we have another point on the graph negative x and y, which is also a point on a graph, this means that the portion of the graph below the x-axis is a mirror of the image above the x-axis. So how we test for symmetry in this situation? So this equation we have here is y squared is equal to 2x. So if we test for symmetry in respect to the x-axis, we will replace the y by negative y and see if we have the equivalent equation. So if we replace y by negative y squared is equal to 2x, we know when we have a negative times a negative, we'll have positive y squared is equal to 2x. So these two equations are equivalent. The last graph we're going to look at is when it is symmetric with respect to the origin. So whenever we have a point x and y, and we have another point on the graph which is negative x and negative y, this means that the graph is unchanged by a rotation of 180 degrees about the origin. So how we will test for symmetry in this case is, so we have the function y is equal to 7x to the power of 3 plus x. So how we will test for symmetry is we will replace x by negative x and replace y by negative y and see if it yields an equivalent equation. So let's replace y here with negative y, and here we will have equal to 7 times negative x to the power of 3. So this will give us a negative again and negative x. So now we have negative y is equal to negative 7x to the power of 3 negative x. So if we multiply with a negative right through, we will get y is equal to 7x to the power of 3 plus x. So these two equations is equivalent. So we can see our equation is symmetric with respect to the origin. In the following example, we need to test for symmetry with respect to each axis and the origin. So we have the function y to the power of 2 is equal to x to the power of 3 minus 8x. So if we go test first in respect to the x-axis, so remember we'll replace y with negative y. Okay, and then we'll see if it will give us the equivalent equation. So we will have negative y squared is equal to x to the power of 3 minus 8x. So if we have a negative times a negative, it will be a positive. So we'll have y squared is equal to x to the power of 3 minus 8x. So we see that these two are equivalent. So there is symmetry in the x-axis. So let's go test now for the y-axis. And we're going to replace x by negative x. So we're going to have y squared is equal to negative x to the power of 3 minus 8 times negative x. So here we'll have y squared is equal to, so a negative times a negative is a positive times a negative. That will give us negative x to the power of 3. And here we have negative 8 times negative x. So we'll have positive 8x. So now we can see that these two are not equivalent. So we have no symmetry in the y-axis. And lastly, if we're going to go test if there is any symmetry in the origin, we're going to replace y by negative y and x by negative x. So we're going to have negative y squared is equal to negative x to the power of 3 minus 8 times negative x. So this will give us y squared is equal to negative x to the power of 3 plus 8x. So we're going to see again we don't have a equivalent equation. So we will only have symmetry in terms of the x-axis. So let's go plot this function in Desmos and we can see how does the function look like. So here we have our function that's plotted in Desmos. So we'll see for any x and y value, we will have a x and negative y value. So we can see we have symmetry in our x-axis.
The next concept we will look at is point of intersection. A point of intersection of graphs of two equations is the point where it satisfies both equations. This point can be found if we solve both equations simultaneously. This means that we will put the equations equal to each other. Let's look at the following two examples together.
In this example, they ask us to find the point of intersection of the graphs of the equations. So we have been given two equations, x squared plus y is equal to 15 and minus 3x plus y is equal to 11. So let's go and rewrite this in terms of y. So our first equation will be y is equal to negative x squared plus 15. And for the second equation, we will have y is equal to 3x plus 11. Now we can go and put these two equations equal to each other. So we're going to have negative x squared plus 15 is equal to 3x plus 11. So let's move everything to the right side. So we're going to add on both sides a plus x squared. So we're going to have a plus x squared minus x squared. That's going to give us a 0. So we're going to have here a x squared plus 3x. So we're going to minus with 15 on both sides. So we're going to have 11 minus 15. That is going to give us negative 4. And 15 minus 15, that will give us a 0. So let's go factorize this. We're going to have 0 is equal to x plus 4. And we're going to have x minus 1. So we're going to have x is equal to negative 4. And x is then equal to 1. So to find the point of intersection, let's go substitute negative 4 in y is equal to 3 times x plus 11. So we're going to substitute negative 4 inside here, plus 11. So we're going to get y is equal to negative 1 for x is equal to negative 4. And for x is equal to 1, we're going to have y is equal to 3 times 1 plus 11. So that will give us y is equal to 14. So the point of intersections will then be negative 4 and negative 1 and 1 and 14. In the following example, we want to find the point of intersection of the graph of the equation 3x minus 2y is equal to negative 4 and 4x plus 2y is equal to negative 10. So let's go and rewrite these two equations in terms of y. So for the first one, we're going to have negative 2y is equal to negative 4 and negative 3x. So if we divide by a negative 2, we will then have that y is equal to 3x plus 4 divided by 2. And for the second equation, we're going to have 2y is equal to negative 10 and negative 4x. So again, we can divide by 2 on both sides. So we're going to have y is equal to negative 4x minus 10 divided by 2. So now we can put these two equations equal to each other. So we're going to have 3x plus 4 divided by 2 is equal to negative 4x minus 10 divided by 2. So if we go and multiply with a 2 throughout, we're only going to be left with 3x plus 4 is equal to minus 4x minus 10. So if we add plus 4x on both sides, we're going to have here a 7x plus 4 is equal to, so minus 4x plus 4x, that's going to be 0, and negative 10. And if we subtract negative 4 on both sides, we're going to have 7x is equal to, so we're going to have plus 4 minus 4, that will give us 0, and minus 10 minus 4, that will give us minus 14. So x is equal to negative 2. So let's go substitute negative 2 in one of our equations to find our y value. So if we substitute negative 2 in this first equation, we will have y is equal to 3 times negative 2 plus 4 divided by 2. So this will give us negative 6 plus 4. So we're going to have negative 2 divided by 2. So we will get y as negative 1. So our point of intersection is negative 2 for the x coordinate and negative 1 for y.
So remember that maths is all about practicing and solving problems. So I'm going to add a few problems here in the end, which I want you to go work through, and I will upload the solution to these problems as well. I hope you learned something useful today, and I will see you then in the next class.